Hello, how are we doing? So we're up to module 4 of Inter-VLAN routing, so of course of switching, routing and wireless essentials. So of course last chapter we spoke about VLANs themselves, and so now we're talking about how we route between different VLANs. Alright, so we're going to look at Inter-VLAN routing operation, and so we'll look at the different options that we can use to do that. And so then we'll look at router on a stick, which is using a router via a trunk link. A layer 3 switch, which is basically having a core switch or something like that that is actually behaving as a router between the VLANs. And then of course we'll look at how to troubleshoot into VLAN routing. Okay, so VLANs are used to segment layer 2 networks for a variety of reasons. Regardless of the reasons, hosts on one VLAN cannot communicate with hosts on another VLAN unless there is a router or a layer 3 switch to provide routing services. So inter-VLAN routing is the process of forwarding network traffic from one VLAN to another. There are 3 inter-VLAN options, and so there's legacy, where basically you have one interface per VLAN on a router, and it does work well, but you have to buy more interfaces if you want to have more VLANs, and so that's sort of less than that's why it says it doesn't scale well. So router on a stick is basically you only have to use one interface on the router, and you can actually create sub interfaces on it that are members of each VLAN, and so you can actually route between those. And then layer 3 switching, which is basically typically you'll use switch virtual interfaces. So up prior to now you've used VLAN 1 or VLAN 99 or whatever it might be, where you can actually with a layer 3 switch you can actually have more than one SVI up at a time, and they are the border between the networks then. And so this is the most scalable solution for medium to large organizations. Okay, so legacy, of course, is where your first inter-VLAN routing solution relied on a router with multiple Ethernet interfaces. Each interface was connected to a switch port on a different VLAN, and the router interfaces served as default gateways to the local hosts on each VLAN. Legacy inter-VLAN routing using physical interfaces works, but has a significant limitation. It is not reasonably scalable because routers have a limited number of physical interfaces. Requiring one physical router interface per VLAN quickly exhausts the physical interface capacity of a router. And so this method of inter-VLAN routing is no longer implemented in switch networks and is included for explanation purposes only. So router on a stick is where you have inter-VLAN routing method overcomes the limitation of the legacy method, requires only one physical interface, and as I said, you can actually create multiple sub-interfaces. So Cisco OS router Ethernet interface is configured as a .1Q trunk connected to a trunk port on the layer 2 switch, and specifically the router interface is configured using sub-interfaces to identify routable VLANs. The configured sub-interfaces are software-based virtual interfaces. Each is associated with a single physical Ethernet interface. Sub-interfaces are configured in software on a router. Each sub-interface is independently configured with an IP address and VLAN assignment. Sub-interfaces are configured for different subnets that correspond to the VLAN assignment. This facilitates the logical routing. So the routers treat each of those sub-interfaces as being separate subnets, and so you can route traffic between the different subnets. When VLAN tag traffic enters the router interface, it is forwarded to the VLAN sub-interface. After a routing decision is made on the destination IP network address, the router determines the exit interface. If the exit interface is configured on a .1Q sub-interface, the data frames are VLAN tagged with a new VLAN and sent back out the physical interface. So note, router on a stick method in a VLAN routing does not scale beyond 50 VLANs. Basically, the more you're sharing, the less bandwidth each VLAN gets. And so the more modern method for doing inter-VLAN routing is a layer 3 switch, and using switch virtual interfaces, as I said. So an SVI is a virtual interface that is configured on a layer 3 switch as shown in the figure. And so a layer 3 switch is also called a multi-layer switch as it operates on layer 2 and layer 3. However, in this course, we'll learn the term layer 3 switch. And so, yeah, you have an SVI for VLAN 10 and another SVI for VLAN 20, and Of course, these addresses are, of course, what the hosts on VLAN 10 would use here and VLAN 20 would use here. And so they end up in the multi-layer switch, and then they get forwarded around. Okay, so in the VLAN, SVIs are created the same way that management VLAN interface is created. The SVI is created for a VLAN that exists on the switch. Although virtual, the SVI performs the same functions for the VLAN as a router interface would. Specifically, it provides layer 3 processing for packets that are sent to or from all switch ports associated with that VLAN. The following advantages of layer 3 switches. And so they're much faster than a router on a stick because everything is in hardware switched and routed. There is no need for external links from the switch to the router for routing. There are no limited to one link because layer 2 ether channels can be used as trunk links between the switches to increase bandwidth. Latency is much lower because the data does not need to leave the switch in order to be routed to a different network. They are more commonly deployed in the campus LAN than routers. The only disadvantage with layer 3 switches is they are more expensive. Okay. So, specifically about router on a stick, basically, as you can see here, we have multiple switches, switch 1 and switch 2. And so to join, and we have multiple VLANs on those switches as well. So to join the switches together, there's a trunk link, and there's another trunk link that joins the router to the switch. And so in the figure, R1 G001 is connected to the S1 interface 05. The S1 fast Ethernet port is connected to S2 fast Ethernet port 1. These are the trunk links that are required to forward traffic within and between VLANs. To route between VLANs, the R1 G001 interface is logically divided into 3 sub-interfaces, as shown in the table. The table also shows the 3 VLANs that will be configured on the switches. Assume that R1, S1, and S2 have initial basic configurations. Currently, PC1 and PC2 cannot ping each other because they are on separate networks. Only S1 and S2 can ping each other, but they are unreachable by PC1 and PC2 because they're on different networks. To enable devices to ping each other, the switches must be configured with VLANs and trunking, and the router must be configured with inter-VLAN routing. So, so PC1 is on VLAN 10, PC2 is on VLAN 20, 99 I'm assuming are the management ports on the switches. All right, so complete the steps. So you create and name the VLANs on the switches, create the management interface, configure access ports, and configure trunking ports. Of course, all of that was what we spoke about in the previous chapter. And so here's an example. And so here we keep creating VLAN 10, we're calling it LAN 10, VLAN 20, LAN 20, and VLAN 99 management. And so that's on the switch. And then here, of course, the management VLAN is interface VLAN 99, give it an IP address, turn it on, tell it who its gateway is, all good. And then here, we're making port 18 a member of VLAN 20, and we're making fast Ethernet 1 a trunk port. So that's on switch 2. Of course, that's the one that's only connected to the other switch and not connected to the router. So the router on the stick method requires you to create a sub-interface for each VLAN to be routed. The sub-interface is created using interface ID, sub-interface ID, global configuration mode command. The sub-interface syntax is the physical interface followed by a period and a sub-interface number. Although not required, it is customary to match the sub-interface number with the VLAN number just to make things easier. So you name the sub-interface, and then you need to specify what VLAN it belongs to by doing encapsulation.1q. Of course, that's how the VLANs are tagged. And then VLAN ID, 10, 20, or 99. And then there is the option to use native. And so we spoke about native VLANs in the previous chapter. So, of course, they're untagged. And the native keyword option is only appended to set the native VLAN to something other than VLAN 1. So, of course, then you need to set an IP address for that subnet. Of course, it needs to be for that particular VLAN. So you repeat the process for each VLAN that needs to be routed. Each router sub-interface must be assigned an IP address on a unique subnet for routing to occur. When all sub-interfaces have been created, you then configure the physical interface by just turning on by no shutdown. And then as long as your trunk links up and talking to the switch, it will work. So this is an explanation of how you do that. And so as you can see here, it's G001.10. And so the sub interface, of course, is .10. And encapsulation .1Q10. Of course, that means it's VLAN 10. And so it could be 001.1. That would work just as well and still have .1Q10. That would work, but it gets confusing. And so that's why it's good practice to have the same numbers. And so here, of course, we've got the same third octet as well. So there's a whole pile of 10s for that. And so, yeah, so you do the sub-interface name. Description, of course, is optional, but a good idea. Encapsulation, of course, tells us what the tag is going to be. And, of course, then it needs the layer 3 addressing. So then VLAN 20, again, same process, but just different ID for the interface and tag and subnet. And then 99. And so, again, description, .1Q tag, and the IP address. And then once you've done all those, you just go there. You can put a description in again, and then turn it on, and then all your physical interface will come up, which of course brings all the logical sub interfaces up. Okay. So of course, once you've got routing working, and of course your hosts know who their routers are, you need to test it, basically verify that it's working. So once it's complete, after the switch trunk and the router and sub interfaces have been configured, the configuration can be verified from the host, router, and switch. From a host, verify the connectivity to a host in another VLAN by using the ping command. It's a very good idea to first verify the current host IP address using ipconfig. Then use ping to verify connectivity with PC2 and the switch, and so on. So basically test that everyone can talk to everyone. And so, in addition to using ping, you can do show commands that can be used to verify and troubleshoot. So, of course, show IP route, you would have an entry in the table for each of your subnets or sub interfaces. Show IP interface brief, of course, shows one line per interface. Again, show interfaces and show interfaces trunk. Of course, there is show run as well. Okay, so using a layer 3 switch. So, of course, route on a stick is simple to implement for a small to medium-sized organization. However, large enterprise requires a faster, more scalable method to provide inter-VLAN routing. Enterprise campus LANs use layer 3 switches to provide inter-VLAN routing. Layer 3 switches use hardware-based switching to achieve higher packet processing rates than routers. Layer 3 switches are also commonly implemented in enterprise distribution layer wiring closets. So capabilities of layer 3 switch, they can route from one VLAN to another using multiple switched virtual interfaces. They can convert a layer 2 switch port to a layer 3 interface, so you can actually create a routed port. And so you basically do the no switch port command does that. And to provide inter-VLAN routing, layer 3 switches use SVIs. They are configured using the same interface VLAN ID command used to create the management SVIs. You just have to create one for each VLAN, as opposed to just the management VLAN, what we've done previously. Okay, so here we have two hosts hooked into the one switch. They're still on the two different VLANs, but as long as this D1 is configured properly, they'll be able to talk to one another. Okay, so you need to create the VLANs again. So VLAN 10 and 20 are still required. You need then create the SVIs on D1, and of course they need to have addresses from different subnets. So of course the addressing schemes set out there. Configure access ports, assign the appropriate port to the required VLAN, and so of course that's what it's telling us there. And then of course you need to do the IP routing command so that it will actually route the packets. So switches don't do layer 3 routing by default, so you of course need to turn it on. Okay, so inter-VLAN routing using a layer 3 switch is simpler to configure than the route on a stick. After the configuration is complete, the configuration can be verified again by pinging between hosts and all the other devices, making sure you can all connect. And if VLANs are to be reachable by other layer 3 devices, they must be advertised using static or dynamic routing. To enable routing on a layer 3 switch, a routed port must be configured. A routed port is created on a layer 3 switch by disabling the switch port feature on the layer 2 port that is connected to another layer 3 device. Specifically, as I said, no switch port command for that particular interface. And so that means it's not a switch port anymore, so it's a layer 3 port. Then the interface can be configured with an IPv4 configuration to connect to a router or another layer 3 switch. Of course, you have to have the right model switch for this to happen. The 2960s don't support this. Okay. In the figure, the previously configured D1 layer 3 switch is now connected to R1, and so R1 and D1 are open using Open's shortest path first, or OSPF, as a routing protocol. Assuming the VLAN routing has been successfully implemented on D1, the G001 interface in R1 has been configured and enabled. Additionally, R1 is using OSPF to advertise to networks and so on. No, OSPF routing configuration is covered in another course. In this module, OSPF configuration commands will be given to you in all activities and assessments. It's not required that you understand the configuration in order to enable OSPF routing. So, yeah, because I haven't done routing protocols yet. Okay, so routing configuration on layer 3 switch. So, again, you configure the routed port with the no switch port command. And then you, of course, need to assign an IP address. And no shut the port. Enable routing using IP routing, and then of course you need to configure a routing protocol, and of course show IP route will tell you whether that's working or not. So how do we troubleshoot Inter-VLAN routing? So there are a number of reasons why an Inter-VLAN configuration may not work. All are related to connectivity issues. First, check the physical layer to resolve any issues where a cable might be connected to the wrong port. If the connections are correct, then use the list in the table for other common reasons why Inter-VLAN routing may fail. So missing VLANs, so you haven't configured them all, that's going to cause problems. Switch trunk port issues, and so again, you know, in that diagram you had earlier, you needed the 2 trunk ports, one between the 2 switches, another one between that core switch and the router. Switch access port issues, and so again they have to be assigned to the right VLAN, and of course the right host has to have the right addressing. And then router configuration issues is sub interfaces and or IP addresses are wrong. Okay, so of course that's the previous scenario we had. So VLANs 10, 20, and 99. And of course, router on a stick on R1 and S1 and S2, of course, are just plain layer 2 switches. And so do show interface fast Ethernet 0/6 switch port. And so it'll tell you access mode VLAN 10. So an Inter-VLAN connectivity issue could be caused by a missing VLAN. The VLAN could be missing if it was not created, was accidentally deleted, or it's not allowed on a trunk link. When a VLAN is deleted, any ports assigned to that VLAN become inactive, which is what, of course, that line is telling us there, inactive. They remain associated with the VLAN and thus inactive until you assign them to a new VLAN. And so that's a possible problem where you've got a port in a VLAN that is now not active. So switch trunk port issues. And so another issue for Inter-VLAN routing includes misconfigured switch ports. In a legacy Inter-VLAN solution, this could be caused when the connecting router is not assigned to the correct VLAN. However, the router on a stick solution, the most common cause is misconfigured trunk port. Verify that the port connecting to the router is correctly configured as a trunk link using the show interface trunk command. If that port is missing from the output, examine the configuration of the port with the show running config and see what is going on. Okay, so access port issues. When a problem is suspected with the switch access port configuration, use verification commands to examine the configuration and identify the problem. So here we're looking doing show interface fast Ethernet 6 switch port. And so the common indicator of this issue is the PCs having the correct address configuration, so addressing and gateway and the like, but unable to ping its default gateway. So show VLAN brief or show interface X switch port or show running, you can actually see what's going on there. So it's on VLAN 1, and of course we've only been dealing with 10, 20, and 99, so not much use. And so router So here I think they're implying that there's a bit of a typo. It's now VLAN 100 instead of 10. So basically it is to have a check. So show interfaces include gig 802.1q, and it'll just tell you what it is. And so again, I'd normally just do a show run and make sure it's see what's in there. Okay, so that's the end of the chapter. So of course the summary at the end. And so Inter-VLAN routing is the process of forwarding network traffic from one VLAN to another. Three options include legacy, router on a stick, and layer 3 switching with SVIs. To configure a switch with VLANs and trunking, complete the following steps: create and name the VLANs, create the management interface, configure access ports, and configure trunk ports. So with the router on the stick method, it requires a sub-interface to be created for each VLAN to be routed. A sub-interface is created using the interface ID sub-interface ID command. So interface G000.10. Each router sub-interface must be assigned an IP address and a unique subnet for routing to occur. When all sub-interfaces have been created, the physical interface must be enabled using the no shutdown interface configuration command. Enterprise campus LANs use layer 3 switches to provide inter-VLAN routing. Layer 3 switches use hardware-based switching to achieve higher packet processing rates than routers. Capabilities of layer 3 switch include routing from one VLAN to another using multiple switch SVIs, and converting a layer 2 switch port into a layer 3, so a routed port. To provide inter-VLAN routing, layer 3 switches use SVIs, and they are configured using the same interface VLAN ID command as what we use to create management SVIs on layer 2 switches. Okay, to configure a switch with VLANs and trunking, complete the following steps: create the VLANs, create the SVI interfaces, configure access ports, and you need to enable IP routing. To enable routing on layer 3 switch, a router port must be configured. A router port is created on a layer 3 switch by disabling the switch port feature on a layer 2 port that is connected to another layer 3 device. The interface can be configured with an IPv4 configuration and connect to a router and then another layer 3 switch. To configure a layer 3 switch to route with a router, follow these steps: configure the routed port, enable routing, configure routing, verify routing, and verify connectivity. There are a number of reasons why an inter-VLAN configuration may not work. All are related to connectivity issues such as missing VLANs, switch port issues, switch access port issues, and router configuration issues. VLAN could be missing if it was not created, it was accidentally deleted, or was not allowed on the trunk link. Another issue for inter-VLAN routing includes misconfigured switch ports, and in legacy inter-VLAN solution, a misconfigured switch port could be caused when connecting the router port is not assigned to the correct VLAN. Last one. With a router on a stick solution, the most common cause is misconfigured trunk port. When a problem is suspected with a switch access port, use ping and show interfaces to identify the problem. Router configuration problems with router on a stick are usually related to sub-interface misconfigurations, so you need to verify their status with the show IP interface brief command. There is the logo. So that's it for chapter 4. Have a good one. See you later.